What is web? So let's have it. That is it's just like an article. That is our website. Now, when we move forward, technology got advanced, right? And once technology got advanced, our web applications became our website became web application. Now, have you ever used any application? Variant? Hello. Yeah, have you ever used any application? So, application in mobile application, we have different features, right? We have different features, we have different options. Now, same thing applies on the web application now. Website becomes a web application. Web application, we have the same functions that we have in Android or mobile application. So web application became a dynamic, interactive, different for other users, right? So it is not same for all users. It is different for other users. It has the functionality. Got it? So this is the basic difference of website and web application. Now, this is called Web 1, 1.0. This is called what? Web 2.0. And now we are moving where? We are moving in Web 3. So upcoming future is on Web 3. Okay, this is Web 1 and Web 2. Got it? Now, so in the past, we interact with websites that are static and cannot change in real time. So this means that the traditional websites were statically created to represent specific information, and this information would not change with our interaction. This means that the static web page, right? We cannot change it, or there is no option to, you know, show the content as per the user interaction. This type of web is called Web 1. On the other hand, most websites run on application or Web 2, presenting dynamic content based on user interaction. Let's say, let's understand this. Okay, do I have to explain this further or is it clear for you? Okay, I don't have, right? So, Web 2 basically have login page. Once you log in, it will provide you the detail as per your account. If other person log in, it will provide the detail as per your account. Now, let's talk about web application distribution. Previously, to create a web application, we have to go through or we have to learn the programming languages. But this is not the case in Web 2.0. In Web 2.0, we have some distributions. We can use some distribution to create our dynamic web application. So the first is this. So these are the most popular web distribution, right? We can use it. Obviously, on top we have WordPress, Joomla, and then OpenCart. So there are many open source web applications used by organizations worldwide that can be customized to meet each organization. So these are the open source. Okay. And there are also closed source web application which are usually developed by a certain organization and then sold to another organization or used in organization through subscription models. Okay. So let me so these are the closed source, huh? The first one is open source and this one. And yeah, Garv and Ovis is make notes, huh? Make notes of this because this is very important. Whenever you go for any interview in cybersecurity, right, they will ask you the question from the basics, right? And this is what the basic is. So you have to know this type of thing. This is very important. So this is open source. Now, what is closed source means? Can anyone tell me what is closed source? No. Open source is also developed by an organization, right? WordPress is an organization, right, that develops the product. Yeah. So open source means everyone can use this for free without paying any penny. But the closed source is you have to pay it. Now we have a web application distribution to create a web application. If I want to create a web page, if I want to create a web page, I have two options. I simply go with a free one, right? So the open source platform that provides me functionality to create a web application, or I simply go with the paid one, right? So these are the free ones that provides functionality to create a web application. WordPress is popular thing, right? Even I think 30% of internet website is developed on what 30 or maybe 20%. So you can guess how big the WordPress is. And on the other hand, we have the closed source. So Wix and Shopify, .NET. So this platform charge a monthly subscription from their user to use the functionality of the web application. We can create a web application. Is that clear? Now, the closed source which usually developed by a certain organization, right? And then sold to any organization or used by organization through a monthly subscription pack, like we do in Netflix, right? Same like a Netflix. You pay subscription pack and they'll provide you the functionality. Now, when we use open source or closed source platforms, right, like this, WordPress, OpenCart, Zoom, we have to understand that there are some security risks. We have to understand that there are some security. Let's talk about this security risk. So, the first thing Any successful web application attack can lead significant loss and massive business. Now, since web applications run on the server that may hosted other sensitive information like database like this, right? It is very important for business to provide them a security. And after fixing the issue, it is essential to test it again if they have any security issue or not, right? So, in order to provide a security or to properly pen test the web application, will always come across a various web applications that are designed and configured different. So one of the most current and widely used method for testing web application is OWASP 10. Got it? We have the web application. Now, different web application. These are the free one, right? These are the open one, the closed one. To test any vulnerability of web application, we follow one standard that is called what? Can anyone tell me? That is called OWASP. So we refer this guide test to web application. Now, this guide has some bugs and guide also show us how to test them. So this is a guide, right? So here we have production, this type of thing. I click. So these are the books, right? You have to click on it. And here we have this. So what is vulnerability? It has all the like test cases that we can perform on web application test vulnerability. So you have to go. So here, first we have information gathering. So how to discover information from a web application, how to test it, everything is mentioned here. We can refer the OWASP testing guide, okay, and we can follow the same and test web application. Got it? And this method is widely used. Now, one of the most common procedure is to start by reviewing a web application front-end component as HTML, also known as front-end entity or front-end trinity, and attempt to find such vulnerabilities. Data export. Once all front-end components are thoroughly tested, we would typically review the web application core function, interaction, browsers, and in order to test a web application for security, we can follow the OWASP testing guide. That is very good. And other thing what we can do is we can simply test the code components that we have. That this is a server, right? That this is a server, and this server's HTML, CSS, JavaScript file, right? Now, HTML, CSS, JavaScript, where did this runs? Where did this file runs? Yeah, so it runs on the user's browser, right? So we can check this files for any vulnerability. First thing we have to do. What type of vulnerability we can find by checking HTML, JS, and C? So we can find sensitive data exposure and cross-site scripting. Other thing also we can do. We'll learn about that. Okay. So our first step is to check HTML, right? Check the HTML source code, whether we have sensitive data exposure, or try to, if there is any input field, try to use some HTML code and let's see if the web application is accepting it or not. So this is how we have to check, right? Once you check all these things, then you have to move You have to move further to check the functionality of a web application. Once you check the web application, then you can move with the functionality. So here we have the functionality. Let's say that this is a login page. You check how the login page is working, how login page sends and receive request and response. This is a dashboard page, right? Here you have button view dashboard. Try to see, you click on this button, what happens. Here you have option to upload a file. Try to check how the web application is identifying what file they required. This is how you have to check it. Got it? Any question here? This is what we have. Now let's in our web application. Now you have to understand that no two applications are identical. Web applications are designed and programmed differently, and the backend infrastructure can be set up in many different ways. So whatever application we create, we have to understand that application are not designed as same. So they are designed totally different. And we have app infrastructure, backend. Let's learn about the backend components, infrastructure categories. So web applications layout can be summarized into categories. So first we have web application infrastructure, then we have web application component, and then we have web application architecture. So just remember, no two web applications are identical. This is very important thing. People think that okay, web application design in same way, but that is not. They have a different architecture, they have a different layouts, right? So application layout can be summarized into categories. The first one is web application. The second one is web application component. The third one is web application architect. We'll learn about this thing. Got it? Web application infrastructure, or web application summarized in main three topics. So application infrastructure, application components, architecture. Got it? Now let's understand what this means. Now, web application infrastructure, this defines or describes the structure of required components such as the database needed for the web application function and intendants. The web application can be set up to run a separate server. Essentially, know which database server is needed to, and web application component like UI, UX, this type of thing. And then we have application architecture. So architecture comprises all relationships between the various web application components. So let's understand this. The first thing, web application. Now, web application infrastructure, it has uh, the four, or it has these common things. The most common one can be following. The other web application infrastructure. Application can use many different infrastructure, right? They also called models. So we can call them a models also. So we have this type of model. First one is client server model, one server model, many server, one database model, many server, many database models. Okay. So you might have heard about client server model. Is that clear? So can anyone have heard about one server, many server, one database model? Okay, so always yes, and why do we use that? Okay, we'll go one step forward and discuss this thing. So this is the web application infrastructure, right? So web application infrastructure means the model that we are using. It is a client server model, one server model, many server, many database, this type of model. Now, in client server model, let's understand this is a server model. Got any doubt here? Now this is a client server. We have client here, right? So we have multiple clients and we have one server. Now whenever a client requests something, server job is to provide the response accordingly, right? Now in this model, web application have two types of components. First one is front end, the second one is back end. So we know that front end component always runs on the user browser, right? Back end component runs on the server. Example here, the processor or the server is processing your login information, that is done in server, right? Now let's understand what happened when user visit a link in client side model. I know it is very basics, but you have to understand that in the field of cybersecurity or in the field of web application security, you have to go through the basics. If you don't go with basics, then you'll lag somewhere. Okay, so this is very important. And in this module, we cover total web development module. Okay, so most people, they don't have understanding of web development part. So this module covered this basic thing. So please bear with me. Let's understand. When a user asks thing, server server sends some files, right? This files contains web page, and this web page directly runs on web browser. This thing is clear, right? So server shows the main page that has the UI made with HTML, CSS, and once the user click on the button, the browser again sends an HTTP request. Let's say that user click on this button. So we have a web application. User clicks on this button. Now, if user clicks this, request again go to the server, and server analyze the request, right? Process that request in server side, and as per the request, server sends the response. So this is how this works in client server model. Is that clear? So it can be anything, it might be anything. Login page, add to cart, or this type of function. Now let's let's see how this process work in one server model. So this is a client server model. Just remember one thing, this is a client server model. We have one server model, many server, one database, and many server, many database. Now let's understand how this work in one server. Learn how it works in one server. Now in one server, what happen is everything is in one server. These clients, right? Here we have the clients. They are requesting something, right? And the web application has one server architecture. Now, if any problem occurs on this server, right, then the whole business at risk. If the server is not working properly, then the website that is stored on this server, so the website that is stored on this server that got what, that got deleted, or that is not responsive, or that is not available for the clients, right? These are the clients. If anything happens wrong with the server, then the web application is not available for these type of clients. This is what happened in one server model, because it has only one server. And the problem of one server model is it cannot handle many requests at once. This is the main issue of this. Okay. Hello. Yeah. So this design represents an all egg in one basket approach. If the server has if the server breaks it, or if the server downs, then everything goes down. Now to overcome this, we have many server one database model. Just to overcome this, now let's understand what happened in many database ones. So in many server one database, what happened, we have three different types of servers, or we have four types of servers, right? And these servers are connected to each other, and here we have the database that process user login or user details. Now by mistakenly, or if anything goes wrong with server A, then server B and server C totally working, right? And server A can transfer this request to server B so that it process the request, and these two server can simply communicate with the database, right? So many server approach used in large companies where they have huge traffic. Got it? To distribute the load of each traffic, they use different types of servers, or they use numbers of servers. Like here we have. Is that clear? Any doubt here? But this model has one problem. Can anyone tell me what's the problem that? What is the problem? Yeah, that is the main issue. Because it has the many server, but it has only one database, right? If anything happen on this database, then the whole architecture is failed. To overcome this, again, we have many server, many database approach. Now, in this module, let's first understand many server, one database model. So sharing data is happening, right? Security advantage and protection is also there. So each part of the web application are kept separate, and we have the protection. If one web server is hacked, then the other are safe because they are separate and they can work, right? So this type of things happen. But we have the main problem, that is one database. To overcome this, we have many server, many database. Let's learn how this thing. Now, in many server, many database, we have eight servers, right? And we have same number of servers and same number of database. Now, these database are interconnected. These servers are also interconnected. Here we have client. If one server and one database fails, then they are connected to each other, right? So they can transfer or they can redirect other user requests to this server, and this is how they save their business, right? So if one server, one database damage, again they have these four database, four servers to work with, right? So this is the main advantage. But yeah, it is not pocket friendly. If you want to like set up many database, many server, then you have to pay a lot of money as per many server, one database. Because for this you have to purchase different servers, right? You have to purchase a database also. So that's the thing. Any doubt here? Now let's understand web application components. So the three things that we have, the first one is web application architecture. Now let's understand web application now here. Now, so each web application can have a different number of components. This totally depends on the web application and the functionality that they have. So one and two, these two are required things. The first one is client, and then we have the server, and then we have web servers, web application logic, database, and services like microservices. So microservices are totally optional, right? Third party integration, and have functions, right? So in functions we can have serverless architecture or serverless function. This is what we have in web application component. So client, so you understand what is client, right? You understand what is server. So do I have to explain web server, web logic, database, or curve, always? Do I have to explain these things? So microservices and third-party integration. Okay. Now we have web application architecture. So this is our final part. Okay. So in final part we have the web application architect. This is our web application. Now in web application architecture, the component of a web application are divided into three different layers known as the three-tier architecture. Can anyone know what is three-tier architecture? Okay. Now, a three-tier architecture that every component, whatever we used in our architecture, that is categorized in three layers. The first one is presentation. Second one is application. The third one is data link. Did you know OSI model? Yeah. So we have these layers in OSI model, and in software development, it is a common design for web apps. It is divide the application into three layers that works together. So these are the three layers. Each layers handle different jobs, and this is called three-tiered architecture. It is very common in software development. What is OSI? Then the then you know the layers. Every component divided into those layers. So the first we have is presentation, application, and data link layer. Now, what is presentation layer? Can anyone tell me what is presentation? Okay. Yeah, it is the main layer that client can see, right? So source thing to user. This is what presentation layer do. Application layer is does the application main job. Data link layer is store and manage the information. Now we have to understand these three layers, and we have to understand what type of component we have in these three layers. Before that, let's understand the setup. So this setup like keeps things organized and make app easier to develop and maintain. So here we have the architecture. Let me explain you the architecture. Now this is the architecture, right? So here we have client. Here we have client. We have proxy internet, or you can say we have a reverse proxy. And again, here we have the code web application. We can simply imagine that this is a server. So client server, our main web application code logic, and then we have database, we have third party services, we have microservices. So these all things became a architect. What a core architecture is. We have client, we have server, we have application logic, we have database. Is that clear? The three-tiered architecture. Hmm. Yes, any doubt here? Now let's understand what we have. So here we have the client, right? That is the presentation layer. Now you know what is client, right? So reverse proxy, this act as an intermediate server that forwards request from client browser to your web application. So reverse proxy, what this reverse proxy do is it simply sends the user request to our main web application, and whenever it receives the response, it sends our response to browser. Then we have the application layer. So the core web application server, so this is the web application, right? So this is a core web application server. It comes under application layer. So this is the web application that is hosted on web lister, right? That is simply server that is comes in application. Is that clear? So inside this we have different components. So we have model that validates filters, right? Response caching, and we have other filters. We have these components here. Did you see the different? Yeah, this is in application layer, right? So here this is our main application. It is hosted in this server. It has this. Now here we have the data link layer or data layer. Now can you point what is data layer here? Can anyone point? Yeah, so this is the data link here. We have databases, right? So this is called three-tier architecture. First tier, third tier. Don't forget this thing. This is very important. Most people lack with this. They don't know the architecture, and they again lack. And again, in data link layer or data layer, we have different services like identity providers, right? That is the microservice. Now, can anyone tell me what is microservices? Okay. So no one knows what is microservices, right? Okay, so do you want me to explain this? Okay. So here we have the microservices, right? These are the micro that manage user identities. And so did you ever heard about OAuth authentication or login with Google, login with Facebook, this type of thing whenever you go in some website? This is a different kind of a website. So this is a different kind of a website. So it I can simply sign in. Now here we have the option sign in with Google, Facebook, Apple, X. Now if I click on sign in with Apple, my request directly goes to the Google web server and Google identify my email address. Same with Facebook, same happen with this type of thing. Now for Medium, Google provide one portion, right, that Medium can use in order to provide the authentication. So that is called the microservices. Can be anything. So microservices can be anything. This type of things are microservices. So here we have this type of microservice: authentication, Active Directory. Is that clear? Now, third-party services. Anyone tell me what is the third? Yes, yeah, that is also third. So this is also third-party services. The authentication, right? Because this is not from the website, right? It is from the different provider. So this is also, we can consider this as a third-party service. We have this. We can consider this both as a third-party services. Got it? Yeah, any doubt here? Now here we have the workflow. The user interact with the application through the web browser. Request from client go through the IIS reverse proxy, which forwards them to the core web application. Web application process the request, perform tasks like data validation, caching, and external things using the database or services. Then the application communicates with identity provider microservices to authenticate. If user try to log in, then application perform number three, right? And then they perform, they try to identify the user login details using the identity manager that we have. Let's say Google or Facebook. Now, then a web application also interact with third-party services, microservices for functions like sending emails or SMS. So often we got message verification, email verification, OTP, right? So these are done with microservices. So web applications integrate this type of functionality to their websites. So after processing, the web application sends a response to the client through the reverse proxy. Client receives the response and display the result to the user, right? So this is what happened in web application. So this is how web application actually work, and this is the actual core architecture. So this is what you need to know. Got it? And just a quick uh, important thing here. In modern web application architecture, microservices are typically accessed using APIs, right? So here we have the APIs, right? So GitHub APIs, this APIs, and here we have the microservices. If you want to access or if you want to use OAuth in your website, you just have to go in Google. You just have to log in, and you just have to integrate a Google's login API in your website, and you have that functionality to log in with OAuth, log in with Google, this type of thing. Is that clear? Okay. Now, presentation layer, we have HTML, CSS, JavaScript. We have front-end frameworks like React, Angular, and UI components. Application components, we have web servers, right? Like Apache Nginx that handles HTTP request. Application server that execute a backend logic. Now, you have to understand web server and application, these are two different things. Okay? Can anyone tell me what is web server and what is application server? Anyone? What is the difference in web server and application server? Yes. So web applications only handles HTTP request and response, right, to connect with the website. But application server actually holds the core functionality of our web application. So it is designed with programming languages. So we have the backend languages, right? So we can use backend languages to design application server. Okay. The most common one is Node.js, Django, Ruby, Rails, Spring, right? So it handles business logic, authentication, and APIs also. Now, data link layer. In data link layer, we can simply integrate our databases, right? And this is the microservices. We have the registration page, search page, payment, rating, reviews, right? So these are microservices. Now, I have a web application. I have a web application. I ask you to design this part. This is a login page. Okay. I ask you to design this part, the login page. I ask you to design this part. This is a payment page. And this is what microservices is. Because you both design this part differently or and separately, right? And at the end, what we can do, we can simply do what? We can simply add this component or this part in our website. And whenever we want to change our login page, we just have to design our login page, right? So it won't affect our whole website. In our whole website, we have this component also, right? We have this component also. Got it? So it don't affect our these two components. It only affect these only components. Similarly, if I want to redesign my payment page, I can simply design it here. Okay, so this is what microservices is. But if we create this thing inside a website, then if you want to change the payment page, again we have to design our web application again, right? Because this is where our code is, right? Understand this thing? Any confusion here? Okay. Serverless. Can anyone tell me what is serverless? Can anyone tell me what is serverless architecture? Ovis, any idea about serverless architecture? Third, any idea with serverless architecture? Let's learn serverless architecture, right? Now, what happen is when you want to design a web application, you need a server, right? You need a server, and to have a server, you have to maintain the environment, right? Let's say that this is the environment. You have to first rent a place, and then in that place, you have to add your server. And to save your server, you have to provide some environment, right? Let's say you have to provide the AC, because server cannot run in very warm environment, right? Because if it runs in warm environment, then yeah, the process is very slow. You have to provide the AC, right? The server is connected with the power plug. You have to provide the electricity bill. You have to you have to you have to have a power generator right here to provide a power just in case if there is a power fluctuation, right? So if you own a server, this is what you have to handle it. Got it? Is this clear? Now this is very headache thing to maintain a server. So big companies, what they actually say is, this is that okay, you don't have to maintain a server, right? we going to maintain we're going to maintain a server for you, right? You just have to use our server and you just have to pay yearly or monthly subscription for us. Okay, so here we have one user who wants to develop a website, right? So in that case, if he want to develop a website, now he doesn't want to maintain the server. He doesn't want to rent a room where he has to simply insert a server. What can he do is, he can simply go in platform that provide serverless architecture. So we have the AWS, right? That is Amazon Web Server. So the user directly go in AWS. He simply buys a plan, a subscription, right? And in that subscription, Amazon provides web server, and he can use this server to host web application, right? And on the behalf of user, Amazon, what they did is, Amazon has to care all these things, right? So this is what serverless architecture means. You don't maintain server at your own in serverless architecture, right? Now it's clear. So this is what serverless architecture is, Amazon Web Services. So you can create your account here, or you can try it for free. I think it is free for 1 year. You can learn what is serverless technology, terms and yeah. So they offered three types of subscriptions. I think yeah, the first one is always free, 12 months free, and free trial, right? And what they provide, yeah, obviously they provide computers, database, storage, right, containers, this type of things. So here they also provide serverless architecture. And yeah, here is the price, right? So you can compare. They provide 5 GB of RAM, storage, right? So this type of things. So this is what they provide in serverless architecture. So Google has their own serverless architecture. Got it? Any question here? Now let's talk about front end versus back end. Okay. After this, we'll have one short break, okay, and then we'll resume our class. Is that clear? Now, front end versus back end. So, what is the difference between front end versus back end? So, the difference is that front end has a different component, back end has a different component. This is what the difference is, right? Now, so front end. The front end already has HTML, CSS, and JavaScript. Backend has server and database, right? And if we combine the both thing, then we have full stack. So what is full stack? Yeah, so full stack consists both things, the front end and back end. So in back end we have servers and database. Front end we have HTML, CSS, and so this is why you have heard about I'm a full stack developer, I'm a front end developer, I'm a back end developer. So full stack combines these two things. Now front end. So you know what we have in front end, HTML. Yes, we have some frameworks also, but we do. Now the front end only contains user interface that directly runs on your browser, and this component make up the web page you interact using the HTML, CSS. So this include everything that user sees and interact on a page. For example, HTML defined main page, and CSS controls the design, JavaScript controls part of the function. Now, in modern web application, front-end components are designed to adjust different size and work all. Now, this is a very important thing. This is a very important thing to put here. Now, did you know? I think yeah, in before 10 years, right? 10 years ago, whenever we open a Google, if we open a Google in mobile phone, hit phone, it won't properly open it due to the size of our screen, right? So did you know this? Let's say this is a yeah. Let's your mobile phone Google it's only open like don't open in a full. Why this happen? Because previously the HTML, CSS, and JS is not so responsive. Day after day, they upgrade themselves. Nowadays, modern web application is responsive. Why they are responsive? Because they are using front end what? They are using front end components, right? They are using front end frameworks like React, right? They are using CSS frameworks to design it. They are using JS frameworks. So that is why in modern web application they are more functional, they are more responsive. Now we have to understand that uh, unlike front-end components that are designed to work on any device and any browser, back-end components are designed for specific platform or operating system. Anyone tell me why this happened? Always you are coming from the like development back. You tell me why this happened? Okay, okay, we'll cover it. Now, this specifications allows back-end component to effectively manage tasks like server-side operation, data processing, which are essentials for web application function properly, right? This is what front end is. So front end have three components that can work in every device, right? Doesn't matter what platform you are using. But backend don't run in every device, right? Backend comes with a predefined platform. Let's learn with backend now. This is the main difference. So we have now backend of a web applications run on the server and handles all essentiality that make the web server application. It runs on the server and processes everything needed for web application. It is the part we may never see directly. So there are four main backend components for web application. The first one is backend server, web server, database, and development. This is the four thing that we required backend. And what are they? Backend server, web server, database, and development. Now, backend server, the hardware and the operating system that runs software or that runs software on the application. So this is what the backend server need, and this is what the backend server. Example, let's say if you are in Windows operating system, right, or you are using Linux operating. Now, for Windows operating system, is it possible for you to run a Linux software? OWASP and GURV. Is it possible for you to run the Windows operating system software in Linux? No, not server. I am talking about softwares. So we cannot run the Windows software in Linux software in Windows, right? So that is why, unlike the front end component that are designed to work on any devices or browser, backend components are designed for specific platforms or operating systems. Let's say MySQL or MS SQL is only designed for Windows. We cannot, like, obviously we can use it in Linux also, but if we use it in Linux, then it not work properly, right? Similarly, uh, MariaDB or MongoDB, right? It is work. It is designed to work with Linux. We can also use it in Windows, but again, it won't work as like it was in like Linux operating system, right? So that is the difference. Okay, got it? Ah, ah. So we have Apache and Nginx as a server. So for database, we have MySQL, PostgreSQL. Development frameworks, we have Django. Now, let's learn about web servers. They manage requests from web browsers and handles connection for website. This is the this is what the job of our web server. They only manage request. They only manage request coming from user end. So here's the example: Apache, Nginx, IIS. These are the popular web servers and development free. Now we have development frameworks for front end and for back end also, right? For front end, we can create different things in the framework. Similarly, in back end, the framework is used to create the main part of a website or web application. So here we have the example of popular framework. So this is a Laravel from PHP. So we have ASP.NET Sharp. So Spring, that is Spring is a framework of Java. So we have Django, that is a Python framework. Express, that is a Node.js framework. These type of framework. Now, why do we use frameworks? When we can simply code a backend, then why do we use or why do we need to use a framework? Yes, perfectly. So development frameworks simplify and speed up the process of building web applications by providing pre-built tools and structure for web or for developers, right? So let's say if you are creating a authentication mechanism, so if you are using code, you have to start from scratch. But if you are using framework, it has the code, you just have to modify it. Similarly, we have the same thing in WordPress, right? WordPress, what we have the templates, we have to design it, or we just have to modify as per our need, right? So that's the same. Now here we have the whole backend. This is our backend. We have operating system, right? This is our server. So we have what? We have the web server, we have web application, we have database. So these three. Is that clear? Now, one important thing, you can host each backend component separately on their own server or in, let's say, since we know we have different models, right? So many server and many database model. Let's consider that. So I can simply host. I can simply host my web server here. I can simply host my application here. I can simply database here, and I can simply make connection these servers to exchange the data or to make. This is the important thing. But yeah, it is not pocket friendly since we have to purchase like different servers. So here we have the main tasks of backend component: create core functionality, write essential, manage database, build a reusable code, set up APIs, and integrate remote services and cloud service. Now, since we have this component in backend, right? It is very important for us to secure the backend as we have to secure the front end also, right? Now, for front end, what we did is we simply look the code that we have, right? That is HTML, CSS, and JavaScript, right? But in front end, we don't have access to that code. So how do we secure our backend? Can anyone tell me? For that, again, we need to talk about OWASP. So even though we can't see the backend code, the application can still be attacked. One common method is through injection. How many of you know what is injection? Let's say this is a web application. This is a login page. Now, instead of instead of providing my user credentials, what if I simply add SQL query here? Then this SQL query directly goes to the MySQL or SQL database, right? Now, if the web application is not ready for this type of query, then what our web application directly sends the response of this database, and within that response we will see the user details, right? So let's say that this is a user details. We'll see the user details. This is what injection is. Okay, again, the backend is not accessible, but still we communicate using the parameters, right? Using the input field, because whatever we are providing in the input field, it directly goes to the backend. Got it? Any question here? Now, if web application search functionality isn't properly secured, attacker can use technique like SQL injection, XSS, command injection. These all three are injection attacks. So we have different module for this, where we learn this thing in very deep. Okay. Now, this vulnerability can lead to a serious attacks. Now here we have something that can happen if we perform this type of attack. So permitting invalid data to enter, right? Okay. So just one question from you. What happened here? Why whatever we put, it directly goes to the database? Whose mistake here? Can anyone tell me? What's wrong in this architect? If I add one injection here, let's say if I add SQL injection or SQL command here, directly goes to the database, right? And it directly retrieve the data for me. Correct? Like this. Like this. Here, I simply add SQL query. It provides me this thing, SQL error, syntax error, and it provides me that the backend is simply using MariaDB, right? And this is the version, right? So this is a website. I don't even know this website use what type of database. I don't have the server access, but still I try to send some SQL query, and it tells me that you are using MariaDB. Got it? And I know that MariaDB is for Linux. So I can simply say that, okay, if the database is MariaDB, then the operating system of that server is Apache, not Apache, Linux. Apache is the web. What is wrong here? Or whose mistake is this? So let's understand why this type of things happen. So here are top common mistakes web developer make when they are pen testing. Uh, there are top common mistakes web developers make that pen testers should be aware of, right? So this is what web developers, when they are making their website, right? They don't follow this thing, and we have to know this thing so that we can check web applications properly. Okay, is that clear? Now let's understand the mistakes that web developers generally do when they are making. Now, when they are making the website, right, they don't validate what type of data database has to access or database have to accept or not, right? They don't validate this. So if they don't validate the data, then user can send simply SQL queries, user can send HTML queries, user can send JavaScript queries, right? And if server is not ready for that query, then server react differently, and that leads to a server breaches. Now establishing personally developed security method. To secure a login page, developers, what they did is they simply designed their own uh, security method, right? And if they design their own security method, they don't know about the consequences, right? And we can simply bypass that security methods. Okay, so it's uh, better to use available security methods to provide the security, because that are tested, right? They try to store username and password in plain text. They let user create a weak password. So if anyone create a weak password, we guess that password and we can simply tag that web page, right? They simply store data in unencrypted format. So if we send a SQL query, we receive the database details, right? But if it is encrypted, then that is totally waste for us because we cannot decrypt it. But since developers don't know about this, so they simply store their data in an encrypted format. They are depending excessively on client side, thinking that user cannot do anything, right? Let's say they are putting validation only in client side. They are not validating the data in server side. Okay, so this is what they have, right? And this is what we have to check. They assume nothing will go wrong. They allow sensitive URLs, sensitive variable names in the URL, like slash secret, slash data, slash this type of thing, right? If there is a SQL vulnerability or SQL error like this, the web page, they don't check it, right? So this type of thing, right? They allow external file to upload in their website without any validation. They are not reviewing user actions, meaning they are not monitoring the user activity. They are not adding or they are not using the firewalls. Okay, and these mistakes leads to OWASP top 10 vulnerability for web application. So this is what the OWASP top 10 vulnerability. First we have the broken control, then we have cryptography, we have injection, insecure design, security misconfiguration, vulnerable and outdated component, identification and software and data integrity failure, security login and monitoring failure, server side request forgery. So this is the mistake that developer do, and we have to know this mistake, and this mistake leads to this vulnerability, and this vulnerability comes under the OWASP top 10. Is that clear? Any doubt here? Okay, so no doubt, right? Or do you have any doubt here? Okay, then let's do you need a break, Garv? Okay, so it is let's come at 4. Okay, okay, so we'll resume this after a